The Junkers Ju-390 was one of the most ambitious and imposing aircraft Germany produced during World War II, a true giant of the skies designed to project power across vast distances. At a time when most bombers struggled to reach far-off targets, the Ju-390 was conceived as a long-range heavy bomber and reconnaissance aircraft capable of striking deep into enemy territory. With a wingspan that dwarfed most contemporary planes and the ability to carry a substantial payload, it was intended to give the Luftwaffe the kind of strategic reach that few other aircraft could match. Its sheer size and capabilities made it an engineering marvel, but also a challenge to operate and maintain under the pressures of wartime production and combat. One of the most remarkable aspects of the Ju-390 was its design, which was essentially an enlarged and modified version of the Ju-290. Stretching over 48 meters in wingspan and measuring more than 30 meters in length, it was one of the largest aircraft of the war. The size alone was intimidating, but it also allowed for impressive payload capacity, enabling it to carry bombs, fuel, and even specialized reconnaissance equipment over thousands of kilometers. This range meant that, in theory, the Ju-390 could strike targets that were previously unreachable, extending the Luftwaffe's operational reach far beyond the limits of standard bombers. The Ju-390 was powered by 6 massive BMW 801 radial engines, giving it the thrust necessary to lift its enormous frame into the air. However, managing such a large aircraft was no small task. Pilots and crews had to contend with the challenges of controlling a plane that was incredibly heavy and required careful coordination during takeoff, flight, and landing. Its size made it vulnerable to ground fire during low-altitude operations and difficult to maneuver in combat, meaning that while it could deliver devastating strikes, it also demanded highly skilled crews to operate safely. Engineers had to balance structural integrity with weight, ensuring that the plane could handle both full payloads and long-range missions without compromising performance. The strategic vision for the Ju-390 extended beyond simple bombing missions. Some plans suggested it could be used for reconnaissance over the Atlantic, potentially even targeting locations as far away as North America. While many of these missions were theoretical, the concept alone demonstrates how Germany sought to push the boundaries of aviation to meet its strategic ambitions. The Ju-390's combination of size, range, and payload made it a platform capable of multiple roles, from conventional bombing to reconnaissance and transport, reflecting a level of versatility that few other aircraft could match. Despite its impressive design, the Ju-390 faced significant practical limitations. Very few were built, largely due to the immense resources required and the deteriorating wartime situation Germany faced. By the time it was operational, maintenance was complex, and the aircraft's size made it a target for Allied reconnaissance and bombing efforts. Even so, the Ju-390 remains an extraordinary example of what engineers could achieve when pushing the limits of aeronautical design. It was more than just a bomber. It was a symbol of ambition, attempting to extend the reach of the Luftwaffe into previously unimaginable distances. The legacy of the Ju-390 lies not in the number of missions it flew, but in its audacious concept. It represents a peak of German engineering ambition during World War II, combining massive size with innovative design to create one of the largest and most capable aircraft of its era. While it never changed the outcome of the war, it left an indelible mark on the history of aviation, influencing post-war designs and serving as a reminder of the extraordinary lengths engineers went to in pursuit of technological superiority. The Ju-390 is a testament to the ingenuity, ambition, and challenges of creating a truly massive aircraft capable of spanning continents in an era when such feats were almost unthinkable. The Boeing B-29 Superfortress was more than just a large aircraft. It was a technological marvel and a symbol of America's industrial and military power during World War II. Designed for long-range strategic bombing missions, the B-29 combined size, firepower, and advanced technology in ways that no other bomber had achieved at the time. It represented a major leap forward in aviation engineering, incorporating pressurized cabins, remote-controlled defensive armaments, and powerful engines that allowed it to carry massive payloads over thousands of kilometers. This combination made the B-29 not only one of the biggest aircraft of the war but also one of the most effective in shaping the course of the conflict. The size of the B-29 was staggering. With a wingspan of over 43 meters and a length exceeding 30 meters. It dwarfed many contemporary bombers. This immense frame allowed it to carry up to 20,000 pounds of bombs, giving the United States Army Air Forces the ability to deliver devastating strikes against Japanese cities, industrial centers, and military installations. But size alone was not enough. Engineers had to ensure that such a massive plane could fly long distances, maintain stability at high altitudes, and operate reliably under combat conditions. The result was a sophisticated airframe with state-of-the-art aerodynamics for its time, allowing the B-29 to cruise at speeds up to 357 miles per hour at altitudes exceeding 30,000 feet, well above the range of most Japanese fighters early in its deployment. One of the B-29's most innovative features was its pressurized cabin. For the first time in a heavy bomber, crew members could operate at high altitudes without suffering from hypoxia or extreme cold. This not only improved comfort and operational efficiency but also expanded the tactical options for missions, as the aircraft could fly higher than most defenses could reach. Additionally, the B-29 featured remote-controlled gun turrets, allowing gunners to target enemy fighters from multiple angles while staying safely inside the pressurized sections of the aircraft. This advanced defensive system made it far more survivable than earlier bombers, giving crews a better chance of returning from long missions over heavily defended enemy territory. The B-29's operational history highlights its strategic importance. It was instrumental in the Allied bombing campaigns against Japan, providing the capability to strike targets thousands of kilometers away from bases in the Mariana Islands. The aircraft's long range and heavy payload capacity enabled missions that had previously been impossible, including the deployment of the atomic bombs on Hiroshima and Nagasaki. Missions that not only demonstrated the plane's unique capabilities but also marked a turning point in warfare history. The Superfortress allowed the United States to maintain sustained pressure on Japan, disrupting industry, transportation, and military production while also reshaping the psychological landscape of the war. Despite its impressive capabilities, the B-29 was not without challenges. Early models faced engine overheating, mechanical failures, and difficulties in maintenance due to its complex systems. Crews had to be highly trained to operate the aircraft safely, and missions required careful planning to account for its size and logistical demands. Nevertheless, these challenges were gradually overcome through technical improvements, rigorous training, and the immense industrial capacity of the United States. The B-29's ability to operate in large numbers with sustained effectiveness underscored its significance as a strategic tool rather than just a technological marvel. The legacy of the B-29 Superfortress is profound. It set new standards for bomber design, combining size, speed, range, and advanced technology in ways that influenced post-war aviation for decades. Beyond its engineering feats, it demonstrated the strategic value of long-range bombers in modern warfare, showing how air power could shape the outcome of conflicts across entire continents. The B-29 was not merely one of the biggest aircraft of World War II. It was one of the most revolutionary, leaving a lasting imprint on military aviation history and solidifying its place as an icon of aerial power and ingenuity. The Messerschmitt Me 323 Gigant was one of the most remarkable transport aircraft of World War II, and its sheer size made it instantly recognizable. Unlike bombers or fighters, the Me 323 was designed not to engage in dogfights or deliver devastating payloads to enemy cities, but to carry massive amounts of troops, vehicles, and supplies directly to the front lines. In a conflict defined by mobility and logistics, the Me 323 was Germany's answer to the challenge of moving heavy equipment over long distances, particularly during campaigns in North Africa and the Eastern Front. It was slow and lumbering, but its ability to transport tanks, artillery, and hundreds of soldiers in a single sortie made it a game-changer for airborne operations and strategic planning. The design of the Me 323 reflected its specialized mission. With a wingspan of over 55 meters and a length exceeding 28 meters, it was one of the largest aircraft Germany produced during the war. The plane was powered by 6 radial engines, a necessity to lift its enormous frame and cargo, and its high wing design allowed for a cavernous fuselage capable of holding tanks, trucks, and large numbers of troops. The landing gear was reinforced to handle heavy loads on uneven and improvised airstrips, which was essential for operations in remote theaters of war. Its open, spacious cargo area allowed for rapid loading and unloading, a critical factor when supporting advancing forces or supplying isolated units. Despite its impressive carrying capacity, the Me-323 was not without vulnerabilities. Its size and slow cruising speed made it an easy target for enemy fighters and anti-aircraft fire. Often, these planes had to fly with fighter escorts or at low altitudes to avoid interception, and many were lost during supply missions. The aircraft's lack of speed and agility meant that pilots had to carefully plan flight paths and avoid heavily defended airspace whenever possible. Even so, the Me-323's ability to carry enormous payloads often justified the risk, as each successful mission could deliver dozens of tons of equipment and hundreds of soldiers to the front lines, sometimes altering the course of localized operations. The logistical importance of the Me-323 cannot be overstated. In campaigns where roads were impassable or territories were contested, moving vehicles, artillery, and supplies by air became a necessity. The Me-323 allowed the Wehrmacht to sustain operations far from supply depots and provided the flexibility to reinforce positions quickly. Its capacity to carry tanks like the Panzer III or IV meant that Germany could attempt to deploy armored forces to critical points with greater speed than traditional overland routes allowed. In theaters like North Africa, where desert terrain made conventional transport challenging, the Me-323 was essential for maintaining operational momentum and keeping forces supplied. Interestingly, the aircraft's design was adapted from the smaller Me-321 glider, which was initially towed into battle by other aircraft. Engineers quickly realized that powered flight would improve mobility and reduce reliance on towing, leading to the development of the six-engine Me-323. This evolution demonstrated Germany's ability to innovate under pressure, translating a cumbersome glider into a fully powered transport capable of carrying enormous loads over considerable distances. It also highlights the interplay between necessity and engineering ingenuity in wartime aircraft development. While the Me-323 was never fast or glamorous, it earned a place in aviation history as one of the largest and most capable transport planes of World War II. Its slow, lumbering appearance belied a remarkable utility. It was a lifeline for troops and a key tool for sustaining operations in difficult theaters. The aircraft's legacy lies in its demonstration that size and capacity, even at the expense of speed and maneuverability, could have a profound impact on the logistics and strategy of modern warfare. The Me-323 Gigant stands as a testament to the critical role of transport aircraft in shaping the outcome of campaigns and the course of the war. During World War II, the race to build the biggest and most capable aircraft pushed engineers on both sides to explore ideas that often seemed almost unbelievable. Beyond operational giants like the Ju-390, B-29, and Me-323, there were experimental and record-breaking aircraft designed to test the limits of aviation, whether in payload, range, or sheer size. These ambitious projects reflected not only the technological aspirations of the era but also the strategic thinking that drove nations to innovate under the pressures of global conflict. While many of these planes never saw combat or were built in only small numbers, their designs pushed the boundaries of what was possible and laid the groundwork for post-war aviation. One of the most famous examples of such experimentation was the Hughes H-4 Hercules, better known as the Spruce Goose. Although it was completed too late to see action, this enormous flying boat captured the imagination of the world with its massive wingspan of nearly 97 meters, which remains one of the largest ever built. The H-4 was designed to carry hundreds of troops or large amounts of cargo across the Atlantic, circumventing the threat of German U-boats that endangered conventional transport ships. It was constructed primarily from wood due to wartime material shortages, demonstrating ingenuity in both materials and engineering. While it only flew once, the Hughes H-4 symbolized the audacity of engineers to conceive aircraft on a scale that most could barely imagine. Germany, too, pursued extreme designs with operational intent. Variants of the Heinkel He-177, for example, were intended to carry heavy bomb loads over long distances, while experimental modifications pushed the envelope of speed, altitude, and payload capacity. These aircraft often incorporated unusual design solutions, from coupled engines to advanced aerodynamic features. in attempts to overcome the physical limits imposed by size. Even if many of these projects never reached full production, they reflected the relentless drive to create machines that could dominate the air in every possible way, whether by delivering massive payloads or performing long-range reconnaissance. The strategic value of these experimental and record-breaking planes extended beyond their potential combat use. Just the knowledge that a nation was capable of designing such colossal aircraft could have a psychological impact on enemies, suggesting a technological superiority that might not have existed in numbers but was impressive in concept. Moreover, the lessons learned from testing these enormous planes influenced post-war designs, including commercial aviation and the development of modern cargo aircraft capable of transporting enormous payloads over intercontinental distances. In this sense, the experimental giants of World War II bridged the gap between wartime necessity and peacetime innovation. The challenges of operating these aircraft were immense. Pilots and crews had to contend with enormous wingspans, heavy takeoff weights, and engines that pushed the limits of contemporary technology. Fuel consumption was staggering, and maintenance required a level of skill and resources that often limited operational deployment. Despite these constraints, the achievements of these experimental aircraft demonstrated that size, when combined with thoughtful engineering, could overcome some of the limitations that smaller planes faced. They offered a glimpse of what aviation could achieve when boundaries were pushed to extremes. Ultimately, these experimental and record-breaking aircraft represent the boldest aspirations of wartime aviation. They were not just machines. They were symbols of innovation, ambition, and the desire to expand the limits of human capability. While they may not have influenced the outcome of the war directly, they left a lasting legacy in the history of aeronautics, inspiring future generations of engineers and pilots. The H-4 Hercules, Heinkel variants, and other ambitious designs demonstrated that in the world of aviation, size and vision can be as impactful as speed and firepower, reminding us that the pursuit of the extraordinary often begins with daring ideas that challenge what is considered possible.